There is so many spaces where somebody with a mathematics degree can flourish and thrive.
So it's comeback season, and I come back. It's been a minute, huh? I hope you guys are still doing good, are still doing well. So the most question that I get from my students, and this question comes in every year, and I think on this YouTube channel, I've tried my best to cover on such topics, and it's actually careers within the mathematical sciences. You know, And I know you'll Google this stuff, you can Google these things and stuff like that and get the information. But sometimes the information seems to be far fetched. You read the information, but it still doesn't relate to you quite well because, number one, maybe you've never met people who have done mathematics or mathematical sciences who actually go on to work in these companies and stuff like that. And number two, especially in South African universities, well, let me not be general, but I remember as a student, I didn't hear a lot about mathematics careers, to be quite honest with you. And that actually made me to be very lonely in mathematics for some time. And I think is the story with many students who do mathematical sciences. So mathematical sciences is the umbrella term that we actually use for so that it covers mathematics, it covers statistics, actuarial science, computer science, and applied mathematics. So all of those sciences fall under mathematical sciences. Of course, you have some universities who actually even have like programs specifically, maybe a degree in mathematical sciences, where you actually do a bit of all of those things. And some they also include economics. Some universities are also including like business sciences, data sciences, etc., etc. So that is what we call mathematical sciences. So when you're doing mathematical sciences at a university, the thing about it is that unlike doing other degrees, when you're doing law, you're going to be a lawyer, right? When you're doing engineering, you're going to be an engineer. But when you're doing mathematical sciences, or let's say you're doing maths, like I was, I remember when I was doing my honors in mathematics, when I meet people and I tell them that I'm doing an honors in mathematics, people will be like, where are you going to work, Chief? Tell us. You're going to be a teacher? In fact, a lot of people presumed that I'll be a teacher or something along those lines. And then they were correct. But however, they didn't know that there are other careers beyond just teaching in mathematics. And I myself, too, at the time, didn't know that there are other careers out there, you know. So it was frustrating for me. And it's still the same thing for most students. I still get the question of some of my students, some students who are not my students, maybe from other universities, who will be asking me to say, hey, I'm doing a degree in mathematical sciences, or I'm doing a degree in applied maths or in mathematics. Where will I work? I think actuarial science is quite better because when you're doing actuarial science, they're going to be an actuary. It's quite straightforward like that. Um, but there are other people who actually get into the actuarial profession besides going to the actuarial science degree route. They do maths, you know, and then or any mathematical sciences, and after that they actually go and write the board exams. I think we have also had this discussion here with Mtutuzi. Go see, you can check that out, that conversation. But so let's talk about let's get into it. Careers for people who have done mathematical sciences. So let's say you've done maths, you've done applied maths, or maybe statistics. I'll leave actuarial science out because it's quite obvious, and maybe computer science or economic sciences, etc., etc. What are the careers? Of course, you can Google this, and you'll get some, information from Google and stuff like that. But I want to talk about people that I know. I want to talk about people that I've brought onto this channel. So I'm talking about something real, something that I know, right? So to start off with, um, I think right now the biggest, bars um, around mathematical sciences is a career as a quant, as a quantitative analyst. And on this channel, I've interviewed many quants. Not many, I'm exaggerating. But I've had a couple of them actually telling it all about the quant route, how to get into it, what's important, what to study, etc., etc., etc. So I don't want to say more, you know, but I had Kim Lucas on this channel, who is a senior quantitative analyst at NetBank Private Wealth. Oh, just saying that I felt wealthy. I felt like I have money. Imagine saying that I work at NetBank Private Wealth. My goodness. Um, so Kim was a classmate. I mean, not a classmate, but was a resmate. We stayed at the same res at Nokendo. Those Nokondians out there, shout out, you know. And so we were neighbors. And then right now, he has a master's in mathematics, cum laude, from Wits, and he also has a BSc honors in mathematics from Wits. And I think his bachelor's degree was a triple major. I think he was majoring in mathematics and wait, let me just check this up before I butcher everything. So he was majoring in mathematics, corporate finance, and investments and marketing. So that was what he was doing. His bachelor's degree was on that. So yeah, let's hear what Kim says. So most of the time, who are the people that you actually take? Obviously people who come from those backgrounds that have analytical thought process and stuff like that, because I know somebody who has done physics and they're also working as a quant, also I've also met some people with some engineering background who are in the banks, and it's fascinating. It's always fascinating for me. I'm like, so you did chemical engineering and you're in a bank, how interesting is that?
Because again, it comes down to being able to think logically. So most of the time, I mean, it's not set in stone. Most of the time you are looking at people from some sort of quantitative discipline.
Yeah.
Again, it doesn't matter if it's physics. You do so much math in physics. So whether it's physics or engineering or stats, actuarial science or maths or applied maths or whatever the case might be, it's all sort of numerical, analytical fields of study. Look, every now and then you get quants from sort of maybe finance or economics and things like that. So I don't think there's a set rule that's in stone that says no, you have to have this. Again, like I said, it's more, can you think in the right mindset? But I think for the most part, I think companies prefer to tend people from more rigorous math disciplines. And I say that just because I think it's very often a lot easier to teach business, the business side of things, than it is to teach the math side of things. Just because I think a lot of, sort of the business acumen that you need within a bank, it's very specific to a bank. And I mean, look, I did some economics. My other degrees in corporate finance and investments. And those gave me great skills to understand what's going on, sort of within the financial sector. But none of them were specific to banking, if that makes sense.
Sure.
And I think banks being so unique, no matter what discipline you come from, you're going to end up having to learn on the job, sort of, the business and finance side of things anyway. So I think it's a lot easier, to take someone from a math science background and, bring them up to speed. And I think that's just what the market seems to prefer at the moment. But like I said, I don't think anything is necessarily set in stone. You definitely do need a degree, though. I will say that. Preferably in honors. Again, it's not set in stone, but just looking at what the market sort of is looking for is really at least an honors degree.
So obviously, Kim is in banking, right? So in banking, obviously, there's a lot of careers in banking which requires mathematics. So if you've done mathematical sciences, you can find yourself in banking. And in fact, I've learned that a lot of people, a lot of mathematical science graduates, actually, they flock into banking or they get recruited by the banks because apparently, allegedly, the banks pay well. So those guys are balling out here with moolah, money, zaka. So there's also a lot of careers in banking. I remember even when I was when I was doing my honors, when I was doing my research, I really wanted to be like an analyst because I was doing a lot of analysis, for people who actually do maths at an advanced level, that is second year, third year, even at honors, you do a lot of analysis. You have subjects or courses like, real analysis, etc., etc. And then there, Ziakala, do a lot of proofs, etc. So those who know, you know. So I would read about, careers like investment analyst, price analyst, business analyst, etc., which actually require, to an extent, some sort of analytical skills or an analytical skill set. And I thought that I would actually, juggle in those, So when I was doing my honors, I looked up into those things. But I mean, let's hear about someone who's in banking, exactly in banking. And this is Pidane Tilibali.
Maramina, Maragapana. And today we have Pidane Tilibali in the house, and today we're going to be talking about everything mathematics. Pidane is, I think, he's someone who loves mathematics, and then he even went forward into studying mathematics. He has a Bachelor of Science in Mathematics and Computer Science, an honors as well in mathematics, and a Master of Science in Mathematical Physics, all from the University of the Witwatersrand, or aka VET. So did you always have a picture or an idea of what do people who study maths end up doing at the end of the day? Like when you come to university and when you study and after that you go and work, did you always have a picture of actually what you're going to do?
Yes. I was fortunate enough to be surrounded by people who had the knowledge of what's happening to the industrial or to the real world. So, I mean, I was just told that, if you do maths, or you can go and work at the banks. I mean, maths and the banks. I knew from the beginning that the banks wants mathematicians. So, but I didn't know what do they want them for. But I just knew that the banks like mathematicians.
And now talking about the banks, because you are actually in the banking sector or in the bank industry, and I'm sure someone can ask to say, you have done maths and you're in the banking sector. Like, what are you doing there? They can't connect the two. Like, what do mathematicians or what do people with a maths background do in the banking sector or in the financial sector, that is?
I mean, in order for you to understand what a mathematician would do in the banking sector, one needs to understand what's really mathematics. I mean, like, how are mathematicians trained and what they're trained to do. I like to think of mathematicians as people who are trained to think, rather than who are given ideas and who are given a bulk of knowledge. It's a matter of teaching one's brain how to think. So, in most of going through that rigorous training of being taught how to think in mathematics, proving theorems, spending most time in the abstract world where only you understand the problem that you are solving. So it becomes much more interesting when you go to corporate, because in corporate there are so many formulas which are being used, and those formulas, most of them, they have so many assumptions which they are not really given. I mean, if you see, for example, the Black-Scholes model, so one will say, we'll just see a formula which a normal finance graduate will just see a formula in which he needs to put certain parameters and is going to get this number and he knows the meaning of this number. So when the mathematician comes now, he doesn't see the formula. Now the mathematician has a brain to go to the assumptions and stretch the formulas and also see other possibilities. I mean, it was realized in the late 1980s that it's better now for the banks to go and take people who have a quantitative background and teach them financial knowledge. Then they can do well than someone who do pure finance in the industry, because there you tend to give more insights, and that's what we do.
You know, and that's very great. And I remember one student also once asked me this in class, in fact, and he was like, I see all the maths and all that we're being taught here, but where are we going to use this? You know, am I going to get into some company and they're like, yeah, solve for X, you know, and you are there, you know, factorizing or applying the quadratic equation and stuff like that. And I was like, no, we teach you how to think. We give you analytical skills. You know, we give you problem solving skills, which are the skills that I think right now, especially because we're in the era of innovation, you know, and you're talking about even fourth industrial revolution, coding and everything like that. You'll never understand the code until you understand the maths behind it, of course, depending on what language are you using and everything. In fact, I was even arguing with someone to say, I think that mathematicians can actually make good entrepreneurs because they have already been instilled with a problem-solving mind, because math is always about problem solving, you know, because the question that I always get asked all the time when I tell people I'm doing math is always like, where are you going to work? And stuff like that. So let's look at, besides academia and teaching, where does, you know, opportunities lie for someone who has done mathematics or someone who has done mathematical sciences?
I mean, since I'm more into the banking sector, I'll focus more on what I know. I mean, if you check the high performing hedge fund in the world, it's headed by the guy called Jim Simmons, and he's a mathematician. I mean, as a mathematician, when you go to the financial theory will tell you that there's no arbitrage in the market, that the markets are efficient. So there's no way that you can make risk-free profit by anything, because like they assume that the knowledge is already there, everyone has equal knowledge in the world. Then they come this new school of thought of mathematicians who are coming to say that we can indeed find patterns in financial markets that we can exploit and make profit out of them. So, which means that now you have more trading moving towards algorithmic trading. I mean, like, you can't really make an algorithm. An algorithm, you have to think of a mathematical pattern or a form of or a formula that needs to follow in order for you to program that algorithm. So that's when mathematics is going. And now the one who also mentioned with the rise of new passive investment strategies. I mean, the passive investment strategies is more where the funds are just following a certain index. I mean, there are some indexes which use mathematical formulas, which we just go to the data and apply those mathematical formulas to the data and analyze it and see and buy stocks according to such formulas. So it has been proven, I mean, using the historical data that those ETFs, in fact, they perform well. I mean, even the hedge fund led by Jim Simmons, I mean, if you check it and if you read more about it, you will just realize that he just have his own mathematical formula that he's using, equations that he's using to solve the market. So it becomes much more interesting in that way. Also in risk management, I mean, as a mathematician in risk management, you're able to see other variables, many variables that can really affect the returns on the portfolio that you are managing. I mean, that's why most mathematicians they go to risk management, and some mathematicians, I mean, they go to pricing. I mean, for actual trading to the in markets. I mean, because like if you are a mathematician, you're able to exploit different situations to your advantage, because you are in a world where I mean, if you check topology, for instance, I mean, you tend to focus more into detail, and you tend to know. People will argue that you know too much of small things, but one will also argue that if there's too much of small things, just means that it was ignorance to the beginning. Those things which people thought it was small, it's not small anymore.
Yeah.
Yes.
And then, of course, one other career that a lot of maths graduates actually get into is consulting. Now consulting makes sense, man. It makes sense, especially when you are a mathematical science graduate. It just makes sense because what I've learned about consulting and what I've been told about consulting from people who are in consulting is that you actually have different problems. It's like consulting here, we don't mean like consulting like call center vibes. No. We talk about consulting. How do I explain this? I don't even know how to explain this. But consulting as a career is not call center. It's actually like consulting on. So you have consulting firms or consulting companies, which actually their main role is just to solve problems of other companies or of other entities, depending on what are the categories that they want to look into. So what I've been told that consulting entails is that you might be solving some agricultural problem. Next thing, you're solving a mining problem. Next thing, you're solving, so that appealed to me because when I was doing mathematics, and that's the thing about doing mathematics, which sometimes doesn't make sense, and a lot of mathematics students and mathematical science students can relate to this. But if you're doing statistics, etc., there's some application to it. But if you're doing pure maths, like it's just too abstract. And sometimes you ask yourself, like, hey, where will I use this? In fact, a lot of students would come at me and be like, what is with this? Because it's too abstract and there is no context to it. It's just too much into the maths and everything like that. They can't find where can they apply this and stuff. So, and I get them, and my answer is always, ish, yeah, guys, I know, right? Yeah, I know, but what you get from those abstract subjects is that they hone or they enhance your analytical skills. They also enhance your innovative and creative skills. And I know when you're doing those subjects, you don't see that. It's like, how am I being creative in a proof? How am I being innovative in a proof? But trust me, it is there. Hear from me. Just believe me at this point. It's happy, And and obviously your problem solving skills. So I think that if you've done maths, you can literally get anywhere and do anything, you know. And I'm not overselling this, but I'm just saying that, you get it. There's a way in which it stretches your mind of how to think and how to apply your mind, because you're constantly thinking. I like what Pidane said today, to say that mathematics, it doesn't tell you that this is this and you produce it as it is. It actually allows you to think. So it teaches you how to think, unlike maybe, say, what is photosynthesis? I'm just giving an example. Photosynthesis will always be photosynthesis. You can't come and define photosynthesis in any other way. It's just photosynthesis. But with mathematics is that we can solve the same problem but using different ways and different approaches, etc. So there is a thought process that goes into it which is unique per person. So there is a way of thinking and then teaching you how to think and how to formulate problems and how to break them down, etc. The same thing happens a lot in engineering, because I also lecture some engineering mathematics, etc., etc. That's why also engineers actually can flock into data science. They can get into maybe the quant space and stuff like that, because engineering as well is a very highly, problem solving, subject in itself. So it gives them that leverage, and they have some coding in it and stuff like that, which is actually good. In fact, I would say that my advice would be, if you're doing any of the mathematical sciences, please also pick some coding, whether you learn by yourself how to code, or you actually pick some courses which have coding in it. Because, guys, coding right now, whether you like it or not, is a skill to have. Even when you go into banking, wherever you go, you need to know how to code at least. Some people learn it at the job. It's possible, it's doable. And so talking about data science, and also talking about consulting, I had a guest actually on the channel, Freddy Sekhapelo. We spoke a lot about consulting. So if you want to check that video out, I'll put it at the description above. So Freddy did a BSc degree, Bachelor of Science degree in mathematics at the University of Pretoria. And he started off as a data scientist. And then from there, he started at African Bank as a data scientist. And then thereafter, he actually transitioned to consulting. So now he's a consultant at Deloitte, if I recall very well. So yeah, let's hear his journey and his thoughts on this. There's a question that actually came here. It said, how did he get into data science after completing his degree?
How did I get into data science after completing my degree?
Your degree. I think you've already touched on that.
Yeah, I feel.
But I think
I feel we've covered that part, but I don't know if there's a specific part of that you wanna mine here.
No, I think maybe the angle that we can look into is the maths degree thing, because a lot of people do a BSc in maths. It's not like, when you're doing law, that you're going to be a lawyer. I think what a lot of mathematics students are facing is that it's unclear to them to say, okay, I'm doing BSc in mathematics. What is this gonna? Because you're solving for things, you're doing theorems and stuff like that. Then they don't see any professional work in that thing. So I think we can answer that from that angle.
And I don't really have them, all at the top of my head now. But I mean, it's one of those things where the answer really is almost everywhere. Genuinely speaking, and it's maybe one thing that I think might be important that people need to think about is developing the skill sets necessary to look for employment. I believe that's an actual skill. How to sift through job sites to find the kinds of things that are fit for your skill set. Because I was also struggling when I first came out of varsity to even imagine where could I work. And really the answer is almost any institution. Because at some point I applied for a job in purchasing. That is where imagine so you can think of it as a retailer, whether it's something like KFC or like a clothing retailer, and then there's a department that sits there that has to decide how much of what we are buying, when and where, and that there's mathematics involved there. There are formulas, there's forecasting. You've got to forecast what your demand is going to look like in the next 12 months. You've got to look at what the cost of purchasing goods are, your relationship with your suppliers, logistics, things like that. So there's a lot of mathematics and modeling that also goes into things like things like that maybe people don't immediately think about. And again, I've applied for jobs in logistics. There was a time when I did that. I've applied for jobs in the telecom space. And so, you think, there's a lot of modeling and mathematics that goes into, that. And as well as, there are companies that do scientific research, medical research. And so I don't really want to, I don't really want to go into a listing exercise, because that one creates a list that people think is exhaustive, but also it relies on my memory, and it also relies on what I'm personally aware of. But the idea is there is so many spaces where somebody with a mathematics degree can flourish and thrive, in a manufacturing context, in I mean, I'm struggling to think of an industry or a business where there aren't people with a mathematics background doing some kind of work there. It's just
True.
that finance is usually the one that comes to mind. It's the easy one that comes to mind, because
Yeah.
finance is nothing but numbers. But, I mean, like I said earlier on, institutions by and large are moving towards data-driven decision making. And so every company has a plethora of data and numerical information that they have sitting with, and they all are trying to find a way to use it to make better business decisions.
So, lastly, the other career in mathematics or mathematical sciences that is underrated, and that's why I'm emphasizing this. This career is underrated because it's what I'm doing. Is being a lecturer, or actually being in the education space. Let me just put it like that. I know some people who do a degree in mathematical sciences or in maths, and thereafter they go and do something called a PGCE, postgraduate certificate in education. And then thereafter they go and teach, in they go and teach maths or mathematical sciences or statistics, etc. at you know at schools and stuff. So that's another career path that somebody can look into. If you're passionate about education, about educating people and stuff like that. I mean, look, there are people who I meet who they do maths, but along the way they realize that actually they have passion for teaching or passion for education, which is actually was my journey. So I think one day I should make a video about how I ended up doing a PhD in mathematics. So yeah, so you can do that, or if you want to be a lecturer in mathematics, yeah, you can go on and maybe do your master's, do your PhD, because usually for most universities to be a lecturer, the minimum requirement is a PhD. Well, you do have some universities who actually can even give you a lecturer role or a lecturer role, even if you're masters, etc. I mean, not etc., but a masters, they can still give you that. But if you want to get into the academic space, that is at university level or at higher institution level, a PhD is a prerequisite, because lecturing people think that as a lecturer, your main job is just to lecture, but that is not our main purpose. In fact, our main purpose is to research. Well, that also depends on the university that you are employed in. So a PhD gives you, that advanced research skills, and because you have to do research and you have to contribute to the discipline. So yeah, but maybe we'll have a video to talk about this. So another option is you can be a lecturer. You can be a lecturer, be an academic, a researcher. And also people think that, if you have a PhD, you can only work, like let's say you want to do research, you can only be limited to universities and high institutions of learning. But that's not the case. You have also in South Africa companies which are research institute, like for example CSIR. I don't know what it stands for, but they're a research entity. So you can work there. They are not a university. They don't teach people, but they do a lot of research. And also a lot of companies these days, they are actually, because of the way things are moving, so a lot of companies now are creating their own research units within the company. So let's say you have a company that has some data science and stuff, then they would have a research unit of data science within the company, because the way the world is evolving right now is that things are changing, and are changing very fast. So you need to be up on your game. You need to actually be ahead. And research is actually that. It's actually digging deep into your subjects and coming up with the juice and using the juice at your advantage to your competitors. So like companies like Google, I know companies like Microsoft, IBM in South Africa, even like companies like YouTube, the platform that we're on, they have a lot of research, that's why the stuff they do is addictive. It's because they have people who really sit down, who do a full blown research about how to make you come back on YouTube or come back at Instagram and stuff like that. They will do all sorts of models, mathematical models included and stuff like that. So research now, I know people who have PhDs in mathematics who go and be directors of some research units in some companies, and they also do well. So I think the scope of mathematics or the mathematical sciences is still gonna be huge. Looking at the way things are going right now, I think we're at a time whereby we really need people who know mathematics than ever before, because like everything, AI, machine learning, computer science, all of these things, the fourth industrial revolution, STEM, all of these things, if you look at what is the foundation, the bare minimum for all of these things happening, the root. I was lecturing on roots the other day in class, and I ended up asking my students that, do they know their roots? Well, that's not the story that I wanted to say. Just came into my mind right now. So yeah, I mean, the root is mathematics. So at least the message I can say to students who are doing mathematical sciences is, please chin up. Please be confident in this thing. You're not lost in this thing. Keep on doing what you do. You're in the right place. Well, I'm not saying things will be smooth, but apply yourself and do things right. Shafere.